Hello everybody and welcome to exercise 3 on page 80 of the workbook. We're just going to be looking at part A of this exercise in this video. Let's take a minute to read the directions here. So for each of the following, you are given a generating set G for a vector space V over R, and we would like to find a subset of G that's a basis for our vector space. Okay, so in the case of part A, G is giving us 4 polynomials, and our vector space is P2 of R, and they'd like us to see if we can find a basis, a subset of G that's a basis for V. Okay, so we might have to throw out some of the polynomials that are there. The question is which ones? Okay, so here's the thing. This is a type of problem that we already know how to do for tuples. Okay, so if this were a problem with tuples instead of polynomials, we could do it. And so the strategy that we're going to use here is to try to translate this into a problem about tuples. Okay, we can do that by first choosing ourselves a nice basis for our vector space. So how about the standard basis? And what we're going to do is to define a new set. I'm going to call it G prime, which is going to contain the coordinate vectors of our polynomials relative to this basis. So if we start with 1 minus 4x plus x squared, for example, how do we build that as a linear combination of our basis vectors? Well, we would just take 1 times 1 plus negative 4 times x plus 1 times x squared, and so we'd get a coordinate vector that looks like 1, negative 4, and 1. Okay, and then we'd move on to the next one, 2 minus 8x plus 2x squared. Its coordinate vector would be 2, negative 8, 2, and so on for all of these. So negative 3, 14, negative 9. And then finally negative 1, 5, and negative 3. Okay, and so that set of coordinate vectors, notice that that's a set of tuples. And here's the key that's going to kind of make our solution work here. There is an isomorphism between our vector space and R3, the set of all 3 tuples. So R3 is isomorphic to P2 of R. We know that because both of those vector spaces have dimension 3. So what that means is that this set here, G prime, that has to form a generating set for R3 because of this isomorphism. Generating set for R3. And so we could ask the question, could we reduce the set G prime to a basis for R3? We can do that because G prime is a set of tuples. And our process for doing that is to start with a matrix where we make those coordinate vectors our columns. Okay, so starting with 1, negative 4, 1. Okay, that's our first coordinate vector. And then we do that for all of the rest of them. So negative 2, 8, 2. Negative 3, 14, negative 9. And then finally negative 1, 5, negative 3. I'm just double checking my matrix to make sure I wrote everything down right. Okay, and then do row reduction on this. You can either do this by hand or probably be easier to do it with an app or something, okay, or a calculator. This gets tedious to always do this by hand. Okay, I'm just going to write down. Okay, and your echelon matrix, depending on what program you use, might look a little bit different than this. Okay, that's all right. Any form of the echelon matrix will work for us. Okay, and the key is to figure out where our pivot positions are. Okay, in this case, they're here, here, and here. Those are the first non-zero entries. Notice that we have a pivot position in the first, third, and the fourth column, and that means that the first, third, and the fourth column, that's going to form a basis for R3. Okay, so beta prime equals, or let's say it this way, a basis for R3 is, okay, and then we'll write down our pivot columns. So 1, negative 4, 1, negative 3, 14, negative 9, and negative 1, 5, and negative 3. Okay, now, how does that help us to answer the question that we were asked? Well, the thing is, because of the isomorphism that we mentioned just a minute ago, if this is a basis for R3, then the corresponding polynomial should be a basis for V. Okay, so which ones are the corresponding polynomials? Well, let's see. So 1, negative 4, 1 goes with this one. Negative 3, 14, negative 9 goes with this one, and then negative 1, 5, negative 3 goes with that one. And so the three polynomials that we wrote down should be a basis for V. Okay, beta equals 1 minus 4x plus x squared, negative 3 plus 14x minus 9x squared, and then finally negative 1 plus 5x minus 3x squared. Okay, and there's our answer.